Welcome to the DIY Honda Garage channel. The DTC P0116 indicates an issue with the Engine Coolant Temperature ECT Sensor 1, specifically signaling a circuit range or performance problem. The ECT sensor is crucial for accurate engine management. It measures the temperature of the engine coolant, allowing the vehicle's engine control module, ECM, to adjust fuel injection and ignition timing for optimal performance. This code can lead to poor engine performance, increased emissions, and potential engine overheating. The ECT sensor is typically located near the thermostat housing, offering a direct temperature reading of the coolant as it circulates through the engine. Accurate functioning of the ECT sensor is vital for maintaining the proper operating temperature and ensuring efficient engine performance. Troubleshooting this code will involve using the Honda Diagnostic System, HDS, to check current data and verifying the sensor's operation under varying temperatures. The Engine Coolant Temperature, ECT Sensor 1, is a pivotal component within the vehicle's cooling system, tasked with measuring the temperature of the engine coolant. By providing accurate temperature readings, the ECT sensor enables the engine control module, ECM, to dynamically adjust fuel delivery and ignition timing, optimizing engine efficiency and performance. Located near the thermostat housing, the ECT sensor is ideally positioned to monitor how hot the engine's coolant becomes as it circulates. When DTC P0116 appears, it suggests a deviation from expected performance or range for this component, potentially affecting the vehicle's operation. With this sensor, any irregularity in its voltage output could indicate wiring issues, sensor faults, or even problems within the ECM itself. It's essential to address any readings that trigger the P0116 code to maintain the vehicle's reliability and performance. The potential causes of DTC P0116 can include an intermittent failure of the ECT Sensor 1, which might manifest sporadically, leading to inconsistent readings. This sort of failure could be related to aging components or environmental factors affecting the sensor's performance. Additionally, poor electrical connections or loose terminals at either the ECT sensor or the engine control module, ECM, can create high resistance or interruptions in signal flow, causing erroneous readings that fall outside the expected parameters. Another consideration would be a faulty ECM itself, which could misinterpret the sensor's signal, leading to erroneous conclusions about coolant temperature. Each of these suspected issues requires careful evaluation to pinpoint the underlying cause effectively. Identifying and addressing the root cause is vital to ensure the system's accurate operation and prevent future DTC occurrences. When facing DTC P0116, several symptoms may manifest that indicate an underlying issue with the engine coolant temperature sensor. One of the most apparent is poor engine performance, which may include sluggish acceleration or poor fuel efficiency. The erroneous readings from the ECT sensor could lead the engine control module, ECM, to mismanage fuel injection or ignition timing, directly impacting vehicle dynamics. Additionally, increased emissions can occur because an incorrect coolant temperature reading may lead to a richer fuel mixture than necessary, exacerbating pollutants released into the atmosphere. Another indication is the illumination of the check engine light, triggering concern for drivers and often resulting in immediate diagnostics. Such symptoms not only affect the driving experience, but could potentially harm the vehicle in the long run if left unaddressed. Recognizing these signs early is critical for prompt intervention. Step 1 in troubleshooting DTC P0116 involves transitioning the vehicle ignition to the on mode without starting the engine. Thereafter, utilizing the Honda Diagnostic System, HDS, to check the current parameters of the ECT Sensor 1. The critical data to observe here is the coolant temperature readings, which should be more than 176 degrees Fahrenheit or over 80 degrees Celsius to signify proper operation. If the values exceed these thresholds, it indicates that the ECT sensor could be functioning appropriately at that moment. By noting the ECT Sensor 1's value at this stage, you gather essential data that directs the next steps. Conversely, if the values do not meet the specified thresholds, it indicates a concerning situation that requires further investigation into the sensor itself or related components. By confirming or denying the sensor's operational status in this step, you're laying a foundation for effective troubleshooting. In troubleshooting step 2, the goal is to verify potential issues arising specifically at low temperatures. First, note the temperature value of ECT Sensor 1 via the HDS within the data list before starting the engine, as this will establish a baseline for comparisons. Once you've documented this data, start the engine and allow it to stabilize while holding the engine's speed at 3,000 RPM without any load, ensuring the vehicle remains in either park or neutral. As the engine operates under these conditions, an important task is to wait until the radiator fan engages, indicating that the engine has reached operational temperatures. Following this, you need to check the ECT Sensor 1 readings once more. The key question here is whether this reading varies by 18 degrees Fahrenheit, 10 degrees Celsius, or more. If it does, it suggests an intermittent failure, meaning the system performs adequately at that moment, but may have underlying issues, pointing towards checking wiring and connections. If it does not change, a consistent problem surfaces, warranting the replacement of ECT Sensor 1. The third troubleshooting step focuses on verifying the ECT sensor's performance at high temperatures. Here, it's essential first to turn the vehicle off and allow the engine to cool for approximately 3 hours, which aids in establishing a controlled environment for testing. Once the cooling period is complete, switch the vehicle back to the on mode and again use the HDS to check the current reading for ECT Sensor 1. The crucial aspect is to determine if the sensor reading changes by 18 degrees Fahrenheit, 10 degrees Celsius or more during this second evaluation. If the reading indicates this significant variation, similar to the previous steps, it implies an intermittent issue where the sensor may work but has some irregularity affecting its reliability. Thus, checking connections and wiring for the ECT sensor and PCM, powertrain control module, becomes essential. If the readings do not change significantly, this suggests a repeatable failure scenario warranting replacement of the ECT Sensor 1 as the next logical step to ensure accurate engine temperature readings. After conducting repairs or component replacements regarding DTC P0116, it's critical to perform a final verification process to confirm the integrity of repairs. First, ensure that the replacement of ECT Sensor 1 has been carried out correctly without any errors regarding installation or connections. Following this, conducting a thorough test drive of the vehicle is immensely important. This provides real-world conditions under which the sensor needs to operate, allowing for the evaluation of performance and monitoring variable temperature ranges. During this drive, continuously observe the engine temperature readings via the HDS to verify consistent and expected values throughout various driving scenarios. Finally, it is essential to return to the query of the diagnostic trouble codes after some driving, allowing the onboard system to reevaluate and ensure no persistent or new DTCs appear. Successfully completing this step assures that the overall problem has been resolved without negative impacts on vehicle performance. Preventive maintenance is crucial to avoid the onset of DTC P0116 relating to the ECT sensor to ensure reliable vehicle performance. A key step in this process is to routinely check the ECT sensor as part of regular maintenance protocols. Assessing its physical condition and electrical connections can prevent contingent failures that may arise due to deterioration or disconnections over time. Equally important is inspecting the wiring leading to the ECT sensor and connectors. Ensuring these are intact and free from corrosion is vital to maintaining accurate signal transmission. Additionally, regular servicing of the coolant system, including checks for fluid levels and quality, is paramount in preventing overheating issues that could compromise sensor functionality. By adopting these preventive measures, a vehicle owner not only prolongs the life of their ECT sensor, but overall vehicle health and efficiency, averting costly repairs ahead. In summary, understanding the role of the engine coolant temperature sensor and the implications of DTC P0116 can significantly contribute to a healthier vehicle operation. This DTC indicates a performance problem that needs systematic troubleshooting to ensure accurate readings and prevent engine performance issues. Following the outlined diagnostic steps methodically allows for a thorough examination of the ECT sensor and other correlated components. Recognizing symptoms early can lead to quicker solutions, preventing long-term damage to the engine or associated systems. Lastly, attention to preventive maintenance ensures that these problems remain in the past. Protecting your investment in the vehicle ensures reliable performance for years to come. Overall, being informed and proactive will result in a better operating Honda Pilot and fewer surprises down the road. Please like and subscribe to the channel. See you next time.